3.3 Function Notation. So when we start with function notation, well, we can start with standard notation. So standard notation is what we've always used. So that standard notation for linear would be y equals mx plus b. Or if we used numbers, y equals 3x plus 2. And we'll use that to start with because we want to use that in our examples. So for example number 1, for function notation, it looks a little differently, but it's just a change in how it looks. So linear is a function because it's not a vertical line, it's a positive slope. So we use that function notation so that we sometimes don't have to write the whole equation over and over and over times, and then we can use it in different ways. So this f of x is how we say it. F of x is the same as your y equals. It's the y part, or what we like to say, the output. So, but I always think about it as that y equals. Now, this is not multiply. It is not a parentheses multiply. Okay, not multiply parentheses. Okay, and that is what's different about this, is that it's a different way to think about it. It's kind of what we call function notation, the f of meaning function of x. And we just kind of say it f of x. We can also use other letters. Typically, the letter after f is g. So g of x, meaning the function of g of x is negative 2x plus 3. And then if we need another one, we'll go to h's because h comes after g. H of x equals x plus 7. So when we change numbers, especially if we're in the same problem, we can use different letters to kind of say this is a different function. If we were to go to another problem, say problem number 7, we can use f of x, define it as a new function because it's a new problem. All right, so in problem number 1, when we have our f of x, we're going to use f of x, which means we're going to use the 3x plus 2, that equation, because that's f of x, we've defined that. And when we say we want to know when x equals 1, so this means when in the past, we had y equals 3x plus 2. And we said in the problem, it said x, I messed up my x equals 1. That's what we're saying here, is just in a different way. It's just a shortened version of that. So we can say, well, when x is 1, we can then substitute 1 in for x and simplify it. So we rewrite it, bring it down. F of 1 equals 3 plus 2 is 5. So when we wrote it, this means, let me draw that arrow there, means when x was 1, y was 5. So we wrote it as a coordinate pair. And that is what we're used to writing as a coordinate pair. But here, do you see how we have the coordinate pair 1, 5? 1 is in the x spot, and 5 is your y, or function of x, f of x, which is the 5. It's the y value. Now, if we used a different number for x, say we wanted to substitute negative 2 in for x, we're going to substitute that -2 in the same place as x. So 3 times -2 plus 2. So f of -2 equals -6 plus 2 is -4. So this means, here's our answer. And what that means is our coordinate pair -2, -4. It's just a function notation way of writing that same thing. So now, that's when we had x as a number. So let's look at example 3, or 2, I should say. If we are given f of x equals 3, that means that 3 is our y. So what that means is when we had y equals 3x plus 2, it asked us when y equals 3. So that's what this f of x equals 3 means. That's what's a little bit different. The x was a little easier when we had to substitute 1 in. This one, we're going to substitute 3 in for that y value. So when we substitute it in, that's going to go in place of the f of x equals 3x plus 2. So we're going to solve for x this time. -2, so 1 equals 3x. Divide both sides by 3. So our x equals 1/3. So how we write that in function notation is f of 1/3 equals, and then remember we're bringing that 3 back over here. And do you see the coordinate pair now? Our coordinate pair is 1/3, 3. The x is 1/3. So we don't have to write it as a coordinate pair. This is a coordinate pair in function notation. All right, so now it gets a little bit more complicated. F of 0 versus f of x equals 0. So what does this mean then? Well, I like this one to start with this one because that's where the f of x was, right? So x is 0. When x was 0 as a coordinate pair, that is our y-intercept. So this one is fine. This is our y-intercept, f of 0. Ooh, I'm going to even do that one in a different color. So let's label this the y-intercept. Well, if that's the y-intercept, that means this one, f of x equals 0. That's the y equals 0, meaning y is 0. So that would be our x-intercept. So let's label this one our x-intercept. And it's a little bit different, so we have to learn a new form of how we do this. So when we substitute, when we want to calculate that, we would take and substitute in for x. So we'll just do that using function notation. F of 0 equals 3 times 0 plus 2. Oh, it's just the b in our y-intercept, because when x is 0, it zeroes this part out, and we're left with f of 0 equals 2. And see how we have our coordinate pair right there for our y-intercept. Now for our x-intercept, that 0 was substituted in for y, so we'll substitute 0 in for that y, f of x, equals 3x plus 2. And now we have to solve for x. 3x equals -2. Divide both sides by 3. So x equals -2/3. So that means my function notation, f of -2/3 equals 0. And that is our y-intercept because y equals 0. The y part equals 0. Now, that's the using the zeros as important points. Now what we're going to do is going to do some solving. So if we have f of x equals g of x. Well, f of x we've been using for a while, so that was 3x plus 2. And we defined g of x at the very beginning. So let's go back up to the very beginning. G of x was -2x plus 3. So we'll pull that back down here and write that down here, -2x plus 3. And now when we substitute those equations in for each of those, hey, we can solve for x. I'll add 2x to both sides. So we get 5x plus 2 equals 3. Get x by itself by dividing by 5 on both sides. So x equals 1/5. Now, the more trickier but fun, I find, it's kind of a little kind of algebra game. If we have g of f of x, it's a little bit more complicated. Now, I made these parentheses a little smaller to kind of help us kind of visualize it. But if you typed it out, this parentheses would be the same as this parentheses, or same height, I should say. Not the same. But do you see how f of x is in the inside where the x is of the g? So I'm going to first substitute f of x in here. And f of x, again, was 3x plus 2. So all I did was substitute f of x in for that. Now, remember when we had the number right here for x? That was the g one. So I'm going to write -2x, but I'm going to put a parentheses because I'm going to have to put this big group in, plus 3. So this is that x, and I'm looking over here, that's this x here, right here. So I'm going to take that group and put it in place of that x. So 3x plus 2 goes right in that spot. So now g of f of x equals, what is it, -6x. That would be a -4 plus 3 would be a -1. So I went back to the original format, and when we substituted one equation in for the other, all we got was a simpler version of that. So now what we're going to do is we are going to graph. Now, you're going to need graph paper. So we're going to graph using function notation. So, number 6. If we graph f of x equals 2x plus 5. So notice that my function notation changed. It was 3x plus 2 for those other problems, but now because this is a new problem, we're going to graph using a new function. So when we do our graph, we're going to make sure that it is nice and organized. Hey, this function is linear. Oh, so I just need to graph 5. Now, you don't want to do this on your paper. You want to do this on your graph paper, not online. I had a hard time getting a piece of graph paper here, so I'm going to graph this one. and I'll probably give it a little bit more. So I'm going to make it even. So now my slope, m equals that change in y over the change in x, is 2 over 1. That means I go up 2 and to the right 1. So, up 2 and to the right 1 would be somewhere in there. But I'm going to go down 2 and to the left 1. 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 So now when we do this, we're going to graph. We're going to use our ruler. Oh, my line is a little off. There we go. All right, let me get back here again. All right, so it's a little easier on your graph paper doing that rather than on the computer. But what we want to do is make sure that we use that slope, and my graph, because I wasn't using line paper, was a little off. And we want to make sure it's nice and clean and straight to the edges, and use a ruler. But we're using that same idea as our slope of linear. Actually, this is a linear function, so we can use that same idea on that. And question, is this discrete or continuous? Even if we made a table, x, y, 0, 5, 1, 7, 2, 9, and so on and so forth. So it looks in the table that it's discrete, but because any number can go for x, we can substitute any number, and that's why we could draw our line. We can substitute an infinite number of points or in for x. Then it is a discrete, no, not discrete, continuous because it's all the infinite number of points in between all of those points also. And that is how you use function notation.